Powered Parachute Handbook 4 Powerplants. Let's dive into the world of aircraft starting systems, where the magic of initiating the engine unfolds. In most small aircraft, a direct cranking electric starter system takes center stage. Picture this system as a coordinated process involving electricity, wiring, switches, solenoids, and a star performer, the starter motor. The starter motor plays a crucial role by engaging the aircraft flywheel or gearbox, setting the engine in motion at just the right speed for a successful start. Our process begins with the supply of electrical power, typically orchestrated by an onboard battery. When the battery switch is flipped on, electricity flows to the main power bus through the battery solenoid. Both the starter and the starter switch draw their share of current from the main bus. However, the starter remains idle until the starting solenoid receives its cue, the starter switch being turned to the start position. As the starter switch takes center stage, energizing the starting solenoid, the starter motor receives its call to action. Initiating rotation, it sets the engine in motion, preparing for the grand entrance of our main character, the engine. This pivotal step marks the beginning of the engine's performance, ready to power the system and fulfill its central role in the operation. But, like any well-choreographed routine, the show must end on a seamless note. When the starter switch is released from the start position, the solenoid gracefully removes power from the starter motor. A touch of technical elegance comes into play here. To protect the starter motor from unwanted encore performances, a clutch in the starter drive allows the engine to outpace the starter motor. This ensures that once the engine takes over, the starter motor gracefully bows out, ready for its next performance. And there you have it, the artistry of aircraft starting systems, where electrical currents, switches, solenoids, and a star-studded starter motor come together for the perfect engine overture. Embark on a journey into the realm of four-stroke engines, where the engine oil system orchestrates a symphony of crucial functions. Picture this as a carefully scripted performance where every component plays a vital role, ensuring the seamless operation of the engine. At the forefront of this performance is the lubrication of the engine's moving parts. Imagine a well-oiled machine, each component gliding smoothly to the rhythm of perfect lubrication. This function serves as the backbone, providing a friction-free environment for the engine's intricate mechanisms. As the performance intensifies, the engine oil system steps into the role of a cooling maestro. It actively reduces friction-generated heat, preventing the engine from succumbing to the pressures of elevated temperatures. This cooling function is a choreographed routine, essential for maintaining the engine's optimal operating conditions. Now, let's talk about keeping your engine cool, a crucial aspect to prevent any overheating issues. You see, when your engine burns fuel, it generates a lot of heat, and we need to manage that heat to keep everything running smoothly. In the world of powered parachutes, there are two main ways we handle this heat: air cooling and liquid cooling. Some engines have this cool feature called a cylinder head temperature (CHT) gauge. It's like the engine's thermometer, telling us what's going on inside. So, air cooling is like nature's air conditioner for your engine. A cooling fan pulls in air, and clever baffles guide it over the engine cylinders, where it soaks up all that excess heat. Then, whoosh, out goes the hot air through openings in the engine shroud. But here's the thing, if your CHT starts acting up and climbing too high, it's like your engine's way of saying, hey, something's not right. It could be issues with lubrication, a worn-out cooling fan belt, or even some unwanted guests building nests in the cooling fins. So, keeping an eye on that CHT gauge is like giving your engine a health check. It's all about making sure things stay cool, calm, and collected up there in the sky. In the midst of the cylinder's spotlight, the engine oil system takes center stage in heat dissipation. It acts as a conductor, directing the flow of heat away from the cylinders, ensuring they deliver a flawless performance without the risk of overheating. Picture the engine's internal space as a well-guarded stage, and the engine oil system as a vigilant custodian. It seals the cylinder's fate with precision, creating an impermeable barrier between the cylinder walls and pistons. This seal is not just a performance element, it's a critical factor for achieving efficient and airtight combustion. As the custodian of cleanliness, the engine oil system sweeps contaminants away with meticulous care. It maintains a pristine environment within the engine, allowing each component to shine without the interference of impurities. Now, shift your focus to the unique routines executed by four-stroke engines. Some engines embrace the straightforward wet sump routine, storing oil directly within the crankcase. Others opt for the intricate dry sump performance, storing oil externally for an added layer of complexity. Each routine contributes to the symphony of function, shaping the engine's artistic expression without missing a beat. When it comes to keeping the engine chill, we've got two players on the field: air cooling and liquid cooling. Now, liquid cooling is like the engine's own hydration system. It pumps coolant through special jackets in the cylinders and head, absorbing all that heat generated during the engine's fiery performance. Once the liquid has done its job soaking up the heat, it takes a trip to the radiator, where the excess heat gets a one-way ticket out to the atmosphere. Then, the now cooled liquid gets a VIP pass back to the engine, ready for another round. If the radiator is strategically placed low and close to the propeller, that spinning prop can be the engine's personal fan club. It keeps the air flowing through the radiator, making sure things stay frosty even when the powered parachute is just hanging out. But, and it's a big but, if the radiator decides to set up camp high and away from the propeller, well, that's when things get tricky. The center of gravity goes up, and the radiator struggles to cool the engine unless we're cruising through the skies. When we're braking in a fresh engine with some ground runs on a scorching day, radiator placement becomes the star of the show. We've got to get it right, or things might heat up in all the wrong ways. Now, liquid-cooled engines, like any diva, can get finicky. Low coolant levels, leaks, a water pump throwing in the towel, or a radiator blockage, any of these can make the engine throw a tantrum. Overheating can cause power loss, detonation, and serious engine damage, emphasizing the importance of timely cooling system maintenance. But here's the plot twist: running the engine below its happy temperature range in cold weather can also spell trouble. Piston seizures and scars on the cylinder walls become the drama of the day, especially when those big radiators designed for summer need a little cozying up in the cold.